So, I was finally able to update my E3V3SE's firmware to 1.0.6. I'm not fully aware of all the changes that this update brings, but I am aware of one important feature change, which changes almost the whole premise of my previous E3V3SE leveling video. So, let's talk about that. This is going to be me trying to give you some recommendations on how to manually level your bed with the 0.6 firmware. Before doing anything, I suggest removing the print surface and tightening the bed screws. This is a big issue amongst these printers and can throw off leveling data by quite a bit. I also suggest checking the x-axis levelness using the glue stick method. They don't have to be glue sticks, but they do have to be two objects of equal height with flat surfaces on the top and bottom of the object. The first thing that I suggest, especially that you have to if you're flashing the new firmware, or at least I think so, it made me, but I recommend that you simply let the machine do one auto leveling and do a test print of the official Creality test print grid. I will hopefully leave a link to it in the description of this video. If not, it's in the description of my last leveling video, which I will also hopefully either link in the description or put it up in the iCard above. So the reason I suggest that you do an initial auto level and bed test print is that it hopefully ensures some safety for your print bed, but also because it will hopefully have at least one pad that is of decent quality. You can typically tell the pad is good based on looking at it and if it feels properly smooth. If you are a beginner and have never physically leveled a printer using the paper method, then let's hope you have at least one good pad. Before we move on, I would like to mention that if you are more experienced with manually leveling 3D printer beds using the printer paper method, then you should adjust your Z offset now. If you are inexperienced, then it might be a good idea just to skip this step. So, looking at the test print model, make sure you have it oriented the right way. There should be a thicker line from the print printing over the initial purge/flow line. This is the bottom left of the bed. It's also usually obvious because typically this corner is pretty messed up when using stock auto leveling data. My best pad was up in the top right corner. It looks the best, all the other ones seem to be a little too close to the bed just by a little bit, or more, and it feels almost completely smooth. Just has a few pokey bits here and there around the edges. Now that you've determined what pad you want to use, get a piece of printer paper and put it in the general area of where your good pad had printed on the bed. From the main menu, select Control, select Edit Level Data, select Edit, then select the corresponding box that matches the position of your selected pad. If your printer is working properly with the 1.0.6 firmware, after selecting the box, your print head should move to the position of the box on all coordinates. So it will move the XY position, but also move its current height in the selected position. So since this was already a decent position, don't edit the data, at least not yet. Just use the paper under the nozzle and move it around a bit. Usually I do up and down movements. This can be hard to get used to, so take your time and really try to internalize this feeling. So now we move to using the whole test print to reference how you should adjust the level data. This will be pretty important if you didn't get any proper pads on your test print and don't know the proper feel of the paper under the nozzle. I will now include some footage that is important for this section of this video from my last video. With your print now off the build surface, we can examine the top and bottom of the print. If you use the Creality test, there should only be one layer, but even so, it's good to inspect the whole model. Before we begin with this list, if you get lost during these explanations, I will try to summarize at the end of them. There are a few anomalies that can occur with high spots, all identified by varying urgencies of holes. If you see full streak holes going along the grain of your print, lower that point by 0.02. These can be identified by seeing through the print, like looking through a small shutter window, or by pushing on a square and not having a solid object that can't wrap around your finger. You see streak gaps, use your best judgment based on the size to decide to lower the point by 0.01 or 0.02. These are identified when you start to have a good square, but there is still a streak of plastic missing. If you have gaps or holes separating your walls from the skin, it's up to you how to decide how to handle this situation. Sometimes this can be a one-off thing with this model, So you can either leave it and observe the spot again on the next print, or you can lower that point by 0.01. This can be identified by obvious separations of the outer lines and the inner square. Low spots, unfortunately for the video, I only have a small experience with, but to my knowledge there would only be 2 outcomes from these low spots. Let's start with your worst option. If you have the nozzle so pressed down on the build plate that you're having a thin line shutter effect, or there's no plastic even coming out, either you have a different issue or your nozzle and bed are probably being damaged and most likely need to be raised by 0.02 or more. I didn't have this issue, so I would lean towards 0.04 or 0.06 just to be safe. Now this one I did encounter at one point. If you have a completed square pad, usually looking good on the bottom, but have a wavy or ribbed top, then you would have a slightly low spot that's pressing a little too close to the plate and is having plastic squish around the nozzle. I suggest raising the point by 0.02. You could take the adjustment slower, but you are rubbing your nozzle through plastic kinda and all that, so I would say be safer than sorrier and just possibly over-raise the point, then continue to have the possible extra wear on your components. You will know you have a good first layer when you have a relatively smooth top to your print without any gaps. But keep in mind that 3D printing isn't always perfect, so there can be minor imperfections. And you will know you have a good first layer when you have a smooth bottom layer with lines that are properly squished together if you have a smoother build surface. If you're using the stock build plate or another textured surface, your first layers should most likely be seamless and will probably have that gritty feel that texture surfaces normally give you. So, to attempt to summarize what we just talked about. If you have a thicker shutter blind effect, you have a bigger tall spot that needs to be lowered. If you have a full plastic streak missing based on the size, you may have a bigger or smaller tall spot. If you have a separation from the outer line and inner skin, it's up to you either to minorly lower the point or to see if it happens again. If you have a thin shutter blind effect or don't have plastic coming out, raise that point a lot, or you may have a different problem. If you have a good bottom but a ribbed top, raise that point by at least 0.02. And finally, you've struck gold if you have a mostly smooth top and a bottom that is seamless or has lines with a good squish. Using this info, you can determine sort of how you need to adjust the level data in addition to how the paper feels under the nozzle. For the people that don't get a good pad, I don't think I'll explain the feel of the paper under the nozzle properly, so I'm going to insert some clips here from some other more professional 3D printing channels and let them explain it.
When the gap is almost closed, we slide the piece of paper back and forth, and the aim is to get the knob just right so we can just feel a little friction on the piece of paper.
Take a piece of paper and slide it under there. So it's pretty loose there, but it's catching pretty good right there. So this is exactly where we want this right here. We don't want it to buckle real tight under there, but we want to feel just a little bit of drag.
So now that we have all the data we can use to our advantage, we now have to adjust the level data using all of the tactics that we just employed. I suggest starting from the bottom left corner and working your way from there. Currently, when you turn the knob to the right, the selection moves vertically until it needs to move to the next column. Put your paper under the first data point area and select it. The head should now move to the proper position and height. Plus, this function now has live movements. This means as you adjust the height on the data, the head moves to match the data. So you can adjust the height live and manually using the feeling of the tension of the paper rather than having to keep guessing the adjustment amounts and repeating the test print. So now you have to go through the whole process of going to every point and feel if the nozzle is too far or too close. The best way to seal the deal is to do the bed level test again to see how you did. If the bed test doesn't turn out to your satisfaction, you have to go back through and adjust the data points again. So the process is the same, but also kind of different. Much of the process from the previous video carries over, but hopefully now the process is just kind of a bit shorter. Now another important detail is that after you get your bed set to the proper position, don't activate the preprint calibration. It will effectively undo all the work you just did. Like in the last video, I recommend writing down the numbers for your current liked bed positions. Do this just in case you accidentally start a print with auto calibration, or you hit the reset configuration button, which is right next to the edit level data button. Also keep in mind that with use, your bed may and probably will shift, especially because of the poor fastening to the Y-axis gantry. And by that I mean the bed screws coming loose. But the plate may also deform in different ways as time goes on, so just keep an eye on your print quality because your written data may go out of date because of these facts. Another important warning is that if you adjust your Z offset after doing all these adjustments, then it will shift your entire plate's data points up or down. You can use this to your advantage if you get all your points to the same feeling friction level, but all the pads still seem to be a bit too close or too far. This would take a fair bit of consistency on your part, but it is possible and a suggestion. So, if you've enjoyed this video or found it informational, please consider leaving a like. I have a few other videos about the E3V3SE, which may help you discover other ways to improve your printer. However, I will warn you that none of the solutions I have explored perfected my printer. But at the same time, the things I tried have helped and worked for other people. I normally do guitar and drum related content, but I do cover a bit of 3D printing related material, including printer reviews, and recently 3D design build vlog style videos. Kind of like an Adam Savage's tested build video, just more in CAD. But anyway, if that sounds good to you, then please consider subscribing. That's all I have to say for now, so I'm gonna say bye-bye.